Hello my friends, in this video I am going to teach you how you can start to write data file for ECLIPSE, Reservoir Simulation ECLIPSE. So what you need to have is the first thing is that you need to have access to the ECLIPSE manual, because we are going to find some keywords in the ECLIPSE manual, and other things that you need to have is a notepad. So you need to have a notepad in your laptops, and I'm pretty sure all of you have that. So what we need to include in the notepad, okay, so in the data file, first let's start with the data file. So what you need to have is to go to the notepad, open the notepad. So this is a notepad that you are going to write the ECLIPSE keywords in this notepad. So just write RUNSPEC. So what is a RUNSPEC? RUNSPEC is the first keyword that I am going to teach you. So just write RUNSPEC and save that. Okay. So how you can save? You go to the desktop or where you want to save the file and change the name to, for example, simulation. This is our first simulation, and change it to all files and change .txt to .data. Okay, so right now if you save the file, you are going to have simulation file here, and this is the data file. How you can, let me close this one, how you can open this file? So you can open this data file using a notepad or notepad plus. So you can use notepad to open the file. Okay, so this is your data file. So what you need to include in this data file? Your data file should have these sections. Okay, so in total we are going to have 8 sections in the data file, which 2 of them are optional, so you can have that, or you maybe don't have those sections in your data file. But in order to run the data file, you need to have other 6 sections in your data file. So your data file should start from RUNSPEC. What is the RUNSPEC? In the RUNSPEC section, you are going to say what is the general description of your model. For example, what is the grid size in the X, Y, and Z direction? How many phases do you have in your model? Okay, for example, you have oil phase, you have water phase, you have gas phase. And what will be the, for example, maximum number of wells in your model? Something like that. It's just very general description of your model. And next section is the grid section. Okay, in the grid section, you are going to define the model that what will be the grid dimension and the shape of the grids, and what will be the porosity, permeability, need to grass of every single grid in your model. Generally, reservoir engineers are getting this section, grid section, from the geology, and they just include the model from the geology model to their data file. But for example, if you want to do the core flooding or very simple reservoir simulation, you can write the grid section manually, and you don't need to include. Edit section is an optional section. Okay, in the edit section, you can edit the different sections of the grid model that you already had. For example, you notice that in the some section you need to change the permeability of the grids. So you can include the grid file from the grid file that comes from the reservoir engineering, and you can edit that. This is optional, and for the basic simulation you may not need to have this edit section even in your data file. You can add fluid and rock properties. For example, what is the relative permeability, what is the capillary pressure, or something like that in the prop section. Okay, so you need to have a prop section in the data file. In the region section, you can divide the grids in the different regions, and you can define different, for example, relative permeability or other things in that sections. Okay, so when you are going to divide the sections in your model, you can use the region one. But right now we don't need this one as well, because this one is optional. In the solution section, you are going to initialize your model. Okay, you are going to say what is the initial pressure and initial saturation for your model, and what will be the initial condition of your model when the simulation starts. And sorry, I guess I repeated solution twice. And in the summary section, you are going to include, say, the model, that what kind of outputs I need from the model. For example, you can say that I want to have a recovery factor, I want to have a well pressure and grid pressure and field pressure and everything from the simulation. So you can tell the model, the simulator, that what you want in the summary section. In the schedule section, which is very important for the reservoir engineering, you are going to define what will be the, for example, production and injection controls. So for example, we are going to inject in the constant pressure, or we are going to inject water in 100 ppl per day, and we are going to produce oil in 200 ppl per day, or something like that. So you are going to define the operating condition in the schedule section. So you have a data file here that I already show you how you can create this data file. So in data file, you need to have all these keywords. Okay, so we already write the RUNSPEC section. So just click enter, and write somewhere grid. Okay, so it says that in this section we are going to have grid, and do that for the other sections as well. So I am pausing the video, and when finished I will back. Okay, I just copied and paste all these keywords, these sections here in my data file. So my data file starts from the RUNSPEC, and I have grid, props, solution, summary, and schedule here. For now, I am ignoring edit and region because they are optional, and we don't want those data file right now. First thing is that how you can have comments in your data file. In order to have comments, you just need to have dash dash in the first of any line, and everything that you are writing after dash dash simulator is considered that as a comment. Okay, so for example, you can write here, this is a simple simulation file. So after dash dash, this is a simulation file is a comment. So simulator is not going to read this section, and when it comes to dash dash, it's gonna skip this section. So I am going to use this dash dash comment to separate these sections. Okay, so I already have RUNSPEC, so just dash dash and some space. I am just going to separate all those sections, so make it a little bit better. And solution section, I'm just separating the different sections. Okay, so I have different sections, and here in this video we are going to focus on the RUNSPEC section. So we are going to write all the required keywords in the RUNSPEC section, and the next video we are going to jump to the grid, props, and so on. Okay, what we need to write in the RUNSPEC section. The most important keywords that you need to include in the RUNSPEC sections are these. Okay, title. What is the title? So in the title, you are going to say that what is this project. It is the just title of your project. So you can write, for example, this is my first simulation, reservoir engineering simulation, or something like that. And other keyword is the dimensions. Dimensions is defining the number of cells in X, Y, and Z direction. Okay, so for example, here you have a reservoir. Okay, and your reservoir in the X direction has a 10 grids. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 grids in the x direction, 10 grids in the y direction, and 3 grids in the z direction. So in the dimensions keyword, okay, the dimensions keyword is going to have 3 numbers. First number indicate that number of cells in the x direction. For example, in this example, we have 10 grids in the x direction, so we need to write 10 there. Number of cells in the y direction, here we have number of cells in the y direction, which is 10, also there. And we have 3 cells in the z direction. So when it comes to the dimensions keyword, we need to write 10, 10, 3 slash. Okay, so let's back for the RUNSPEC section. So first thing is the title. So let's start from that one. Just write search title in the ECLIPSE manual, and you are going to see this title. So click on title, and you are going to jump to the manual of the title. So I suggest that for every single keyword, go to the manual and check the example to see how you need to write, because sometimes the keyword needs, for example, a slash to finish is to end of that key for indicating that that keyword is finished. So, and some keywords needs 2 slash, so it's better to, it's a little bit confusing. So for every single keyword, it's better to back to the reference manual and see how you can use that keyword. For example, here in title, so title says that specify the run title, and you have example. So just copy this example and back in your data file and paste it here. Okay, this is the title, and you need to change this section because this is it depends on your model. Okay, so in the title, for example, we want to say this is a simple reservoir model. So this is the title of our project. Okay, so go to the next one, dimensions. I already explained you what is the dimensions keyword. So what you need to do is just go to the reference manual and search for dimensions. Okay, this is the dimensions keyword, and it says that you can use in ECLIPSE 100, 300, and you need to use in the RUNSPEC section. Yes, we are going to use in the RUNSPEC section, and this is the example. I already showed you that what is the meaning of these keywords. Okay, so let's, here in the dimensions, you are going to have 3 numbers. First number shows the number of cells in x direction, second one in the y direction, and the third one in the z direction. So just copy this, and don't forget to copy slash as well, and come here and paste it here in the RUNSPEC section. So in the RUNSPEC section, we have dimensions, and right now the default value says that we are going to have 10 in the x direction, 3 in the y direction, and 4 cells in the z direction. But for our model, we want to have 10, 10, 3. So 10 in the x direction, 10 cells in the x direction is correct. So we add 10 in the y direction, and we are going to have a 3 cells in the z direction, and this keyword is finishing with a slash. So it's important to have this slash at the end of the keyword. So this keyword is done. What will be the next keyword? Next keyword is gonna be we are going to define the phases in the what phases we have in the model. Okay, definitely if we are going to simulate oil, oil reservoir, we will have oil. Okay, so if you have oil, write oil, and if you have water, gas, and any other phases that you think you are going to have in your model, you need to write in the RUNSPEC section. So I'm sure I will have oil, I will have water and I will have gas in my reservoir. So you need to write those phases in all those phases in the RUNSPEC section. The next keyword is to define what will be the unit in your simulation. Are you going to have field unit, metric units, or lab units in your simulation? What is the difference between these units? For example, in the metric units, length in the metric we can define it with meters, okay, but in the field it's feet, and the lab unit it is centimeter. And time in the metric unit is day, in the field unit is day as well, and the lab unit is hour, and so on. So in the RUNSPEC section you need to decide what units you are going to use in your simulation, and you need to write that one. For example, here say I am going to use a field unit. So back here and choose a field unit. Okay, so write field here, and this defines the unit that you are going to use. Okay, so you can comment that. So this is the unit that I am going to use. Okay, this is it. And also you can write here that these are the possible phases. Okay. Okay. Next step. Next thing that you need to have in the RUNSPEC is a well dimensions keyword. Okay. Well dimensions is defining the maximum number of well and groups in your reservoir. Okay. So let's have one slide here, and then I will show you what's the meaning of that. So in the well dimensions, you are going to have, you can have many numbers. Okay, so you can check the reference manual and see. Let's just jump to the reference manual. Okay, so well dimensions, and here you can have 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can have up to 14 numbers in this keyword. Okay, in the well dimensions keyword. And this reference manual is showing that what is the meaning of the first number, second number, and so on. So the most important ones are first 4 numbers. Okay, the first number is showing the maximum number of wells in your model. How many wells you have in your model, in the reservoir model? Right now you don't know. Okay, but this number is not asking you to tell the exact number. It's saying the maximum number. So you can say, for example, I'm going to have 20 wells, maximum 20 wells in my model. But maybe you're just going to have two wells or 3 wells, and you are not going to use all 20 wells that you defined here. But it's okay, and it's better to write write a high number here, so in case that, to avoid any error. So we can say that for our system 20 is okay, although we are going to just use 2 wells. And the second one is saying that what is the maximum number of grid blocks that is connected to each well. Okay, so you have one, for example, injection well, and you have many grid blocks that's connected to that well. For example, here, if you have one, for example, producer well here, and it comes to the way bottom of your model, you are going to have 1, 3, and 1, 2, 3. You are going to have 3 blocks that are connected to your well. Okay, so 1 is here, 2, and 3. So here in this section, in the second number of the well dimensions, you are going to define what's the maximum number of grids that's connected to the well. And it's better to use a very large number. So in this case, we are going to use 50, but we know that we are not using all those 50. Maybe we are going to use 10 or in this case 3, but it's better to write very large number. And the third number in the well dimension says that what is the number of groups that in your model. For example, imagine you have 3 injection well and 3 water injection well and 2 gas injection well. So you group all 3 water injection well in one group and say that, for example, W injection well, and all those 2 gas injection wells in another group, and you say, for example, G injection group. So this number showing that what is the maximum number of groups that you are expecting to have in your model. So we are not going to, right now in this stage, we are not going to define any group. So yeah, maybe it's gonna, if we want, you can write, for example, 5 or any number, but again, because it's the maximum, so it doesn't matter. And the fourth value says that what is the number of groups, okay, maximum number of wells, okay, in your group. For example, if you define the W injection group, which consists of 3 water injection wells, okay, so the number there is 3 for in that group you have just 3 wells. But again, put it 10 or some large number that you are going to use, but I'm pretty sure that if in this stage you don't need to even define this number. Okay, so right now you can define all these in the web dimensions section. Okay, but sometimes you are saying that, for example, I defined the 20 for this one, the first number, but I really don't know what is the maximum number of the grid block connected to the well. So if you want, if we have some default values in the ECLIPSE 100, so, or in the general in the ECLIPSE, so you want to recall that default value for, instead of, for example, for this 50. What you need to do, you need to just write star there. So if you write 20 star 5 10, it means that for the second value, which indicates the maximum number of grid blocks connected to any well, use the default value. I don't know right now. Okay, so let's back to the well dimensions in the ECLIPSE data file, and you can see that, for example, for the first number, the default value in ECLIPSE is 0, and if you are running E300, the default value is 10. Okay, and you can find default value for any other numbers as well here. So what you need to do is just copy this section and back in your data file and paste it here. So you are saying that I am going to have maximum 20. Let's start from to edit this section based on this. We are saying that I am going to have maximum 20 wells in my system. Yes. And what will be the maximum grid blocks connected? Let's say I am going to have 50. Maximum groups that you are going to have in your model, 5. And maximum number of groups in the model, let's say 10. Maximum number of wells in your group, so I guess it should be well here. And the rest, I don't know. Use just default value. Okay, so one point here is that if you want to use the rest of the values as a default, okay, so you don't need to write anything. So you don't need to, for example, web dimensions has 14, is taking 14 numbers. Okay, so you don't need to write, for example, you already have 4 here, so you don't need to write star 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 so on for the rest 10 of them. Just if you don't want to indicate any number later, So it's just write slash. It means that after this phone number, take everything as a default. And as I said, for example, if you want to say 50, I don't know the 50s, but take the default value, so you can write instead of 50 start. Okay, so it means that you have 20 wells, default value of the number of connected grids, and 510. Or you can change this one as to the default as well. So you have two default values. Okay. The more professional way to write two default values instead of star star is to write, you can write 2 star. It means that first value, which is the number of wells, take it 20. Two other values, take it as a comment. So it's going to take this value and this value as a comment. And fourth value is 10, and the rest is comment. Okay, so in this way you can write you can take the default values as well. So right now we are going to have 50 and 5 here and save it. Okay, what else we need to include in this section? Okay, start. Start keyword is showing that when your simulation should start. Okay, it's the start point of your simulation. If you go to the Eclipse manual and search for start, you will see that it's specified the start day, and you need to write in the RUNSPEC section. And you have one example. For example, start day is 12 February 1987. Okay, so just copy this one and go to your data file here and paste it here. And for you, for example, we are going to say we are going to start the simulation from 01 January, let's say February 2020. So this is the start date for our simulation. The other keywords that you may want to use is the unif out. Unif out means that it unifies the output files. Okay, so for example, instead of having a file in every single time steps, it's going to unify all those time steps, and you are going to have only one file, which is better than having too many files there. So it's unified the output files. So just go to the Eclipse reference manual, click here, and you can say that it says you are going to use in the RUNSPEC section, and there is no example on that, and it says that this keyword has no association data. It means that you don't need to indicate anything for that. It's just like these keywords that we already used: oil, water, gas, or field. We didn't give any number for these units, so keywords. So for the unif out, we don't need to give anything. And also we are going to have messages. Okay, what is the messages? Messages keyword is indicating that the messages keyword is indicating that how you write, how to print and print the messages, comments, warning, and any other messages during the simulation, and when you should stop the simulation. Okay, for example, what kind of messages you can get from the Eclipse? You can get the message, comment, warning, problem, error, or bug messages from the Eclipse. Okay, the message one is not error. Okay, if you get the message, it's just telling some information about your running to you, so you can ignore those messages. When it comes to the comment, this one is also comment is also it is not a it's just showing some information to you. It's a like message, but and warning. Warning says that, for example, if you have a well and you define the well to produce based on the constant rate, and Eclipse in the middle of run it changed to the says that, for example, if you continue with this rate, you are not the equation is not gonna convert. So I switched that to the constant bottom hole pressure. Okay, so this warning is showing that something happened in the run, but there is a solution for that, so you don't need to worry about that, but check those. If it is okay, just ignore that, but if it is not okay, just go back and edit your data file. And you may have problems. For example, you can have some convergence problem in the equations or something like that, and this you are going to see this kind of error problems, and the most important ones are error. Okay, so if you get error, it means that the simulation is not running. Okay, so there is something bad in your data file and something that causes the error, and simulation is not correct. So your purpose should be to minimize problem and to avoid any error. If you get any error, you are not going to run the data file till end. And the bugs is related to the background of the simulation, and it's related to the data. It is related to the code or programming or something like that. So you don't need to get worried about the bug, and I am sure you are not going to have bug in your system. So the purpose is to minimize this error. So why we need to talk about that in the RUNSPEC section? Because sometimes you are getting warning in the warning or something like that in your model, and after, for example, default value of warning, if you don't change default value in the message section, for example, after 10 runs, 10 warnings, your system is going to stop the running. Okay, so it's based on your model. You can modify this. For example, you can say that, okay, print me all the warnings, but stop the simulation after 1000 warning instead of 10 warnings. So you need to indicate 13 numbers in general for the messages section, but the 6 first ones is showing that is showing how to print the messages. For example, when you are running the simulation, the simulator is going to print the messages, comments, and everything. So you are indicating that how many of those messages or comments I want to print or show me during the running. And the next 6 one is defining when the run should stop. For example, if you in this section we are going to say we don't care about message and comments, so put it as a default, but show us 10 warnings. Okay, so show us the last 10 warnings, print those 10 warnings, and for the problem, error, and bugs, just take a default value. I don't care about that. And when you should stop, we should stop the running. For the message and comments, we say we don't care, just take it as a default. But for the warning, we say that if you get 1000 warning, stop the running. Okay, and take other things as a default. So for the message section, we are going to first 2 values is a default. So yes, first 2 values are default. And I want to print 10 warnings, write 10. Next 5 values are default. Yes, this one, next values are default, 5 values are default. And then I want you to stop the simulation after 10,000 warnings. So So stop the simulation after getting 10,000 warning, and the rest is a default. Okay, so you can get these values in the reference manual of the Eclipse. So, and you can have all default values here. You can check the default values and just copy this section and back to your data file and paste it here. Okay, so you show that we want to and you, in this way, you change the default values for the warning, printing the warning and stop the run for the warning. Save the file, and pretty much this is what you should have in the RUNSPEC section to run the model. But you may have some other keywords as well, so I am going to quickly show you what are the other keywords. You may use nosim keyword. What is the nosim? Nosim is that check my data file, find the errors in my data file, okay, but don't run the simulation. Okay, you need to be careful when you are using the nosim one keyword, because when you are using this nosim one, the simulation is not gonna run. It's just going to check your data file and see if you have any error in data file or not. So when you have a model that's taking too long, it's better to have this keyword in the RUNSPEC section. Just check the your data file before running. But if your data file is not very heavy run, so it's just couple seconds, you don't need to have this one in your RUNSPEC. And another important keyword in the RUNSPEC is the tap times. So it's exactly the same as well times that we show that in well times we indicate the model that how many wells we have in the model and how we are grouping them. So in the tap times we are indicating the simulator that how many tables, saturation tables we are going to have in our model. So this tap times is very useful when you want to, for example, simulate the hysteresis method, and you have, for example, one drainage saturation and one imbibition saturation data point. So you need to indicate the number of data those tables in the data file. But you already know that what you need to do is just copy this keyword, go to the reference manual and check what is the meaning of different values and back to your data file. So here we completed the RUNSPEC section and we wrote every single important keywords for the RUNSPEC section, which is including title, dimensions, and phases, and the unit that we are going to use, well dimensions that we have, and start point, and we indicate that we suggest that unit out all the output files and how many messages we want to print and how many when you need to stop the simulation. So RUNSPEC section is done. In the next video we are going to complete grid section.